I have a question to ask. Every time we manufacture 1 ton of steel, uh, would you be able to tell me how many kgs of carbon dioxide we are emitting into the atmosphere? Like anybody, like approximate number would also be fine. Any guesses at least?
1 to 2 tons.
Sorry?
1 to 2 tons of CO2.
Okay, you're on, I mean, it's almost there, but thank you for at least giving it an attempt. So, today if I had to tell you, every time you use a rebar, every time, anybody else wants to take a guess, I would say it's a very huge range that you mentioned, but
1.9 tons.
Sorry?
1.9 tons.
Yeah, that's more close to it actually. Depends on the product also eventually, but then what we generally say is it is about 2,500 kgs of carbon dioxide. Every time you manufacture 1 ton of steel, every time you use 1 ton of steel, this is what you're actually emitting into the atmosphere as global warming CO2 emissions, right? Now, I'm from ArcelorMittal. We developed a product called Xcarb, where we've actually brought this significantly down from 2,500 kgs of carbon dioxide to a level of 330. Yeah, to a level of 330. How have we done this? We basically use recycled material, which is scrap. We have a processing unit which mostly is from automobile manufacturers, and the second and the most important thing is we actually use renewable sources of energy. It could be wind, it could be hydro, it could be solar, but that is what we do. Now, in our plant, we have an annual capacity of almost 2 million tons. I'm not saying that the entire 2 million tons is being manufactured as green steel. A certain percentage, probably 10, probably 15%, as per the customer's requirement, as per what they need, we use the source of energy as renewable sources, enabling us to bring it down from a level of 1,900, 2,000, 2,500 to as low as 330. In the morning, people talked about sustainability. You know, it is a very hot topic that people are talking about, but what actually are we doing about it? Other than currently what we see in India is mostly with respect to the LEED certifications and the points associated with it. But other than that, I would really, looking at what and all can be done is a factor that we will have to actually think of, at least in the future. Speaking about our product, so we basically are into the manufacturing of structural steel sections. If I had to give you a comparison as to what is available domestically, you will see that you probably get a section weight. When I say section weight, it's basically the kg per meter would be around 340, 350 kgs per meter. That is what you typically get in India. What we manufacture is as high as 1.3 tons per meter. I'm not saying that we do not do a 340 kg or we do not do a UB610 or a UB or a UC306. But we can actually go up to 1.3 tons per meter. And this is in case of UC sections. In case of UV sections, we actually even go up to 1.377. Extremely huge. It's pretty much like 5 times as what is available currently in the country. In addition to this, where does this actually come into play? Today you see that a lot of times, because of the unavailability of the rolled sections, you are actually having to use built-up or plate fabricated sections. Rather than going for that fabrication, rather than having to bust out 2,500 kgs of carbon dioxide every time you use that one plate section, you could actually probably use a roll section, which I don't really have to reiterate. Many people have gone through this exercise where they've compared why roll sections are better, much better in fact, compared to a built-up section. Even our codes in IS also says this in terms of the buckling classes as well. And a second thing is we also manufacture up to 550 MPa, and this is readily available. This is not something like we tell you, okay, why don't you design with it, and then we come back and tell you, probably this is not available. We have the projects to back it up also. 550, we actually manufacture it in ASTM specifications. And very soon we'll also be launching 600 MPa as well. Okay, enough of product. I'll just probably give you a little bit of tidbit for the next 3-4 minutes on how much of a difference various structural elements can actually bring in terms of carbon dioxide emissions. So what we've basically done is these are actual case studies that we've done across the world, wherein which we've compared. If you had to look at a building in terms of its steel intensity in kg per square meter, starting from a very small, a very low intensive building to an extremely high intensive building, typically when you use a plate or a tube or a built-up section, which generally comes from a blast furnace, you see it is as close as 400 kgs of carbon dioxide that you are emitting per square meter. That is what you typically emit if it is a very steel intensive building. We actually bring that down to as low as 75. So that's almost, sorry, 170. It varies between, I mean, the difference that we can actually bring is around close to 225 kgs of carbon dioxide of emissions per square meter. This is actually a data center project that we had done in Bombay, where initially it was in concrete, then we got it shifted into steel. This was the initial RC solution. Obviously, we made it into a much sleeker steel frame, which includes not just UV/UC sections, but also a composite floor along with it. And if you look at it, again, the intensity over here was in the range of 400, where we've been able to reduce it by around 257. So this is the actual scope 3 savings that you get for the client. I don't know how many of you know it, but it has already been published that data centers are going to contribute to 2 to 3% of the global emissions in the world. And India is becoming a huge hub for data centers. You take a call as to what type of material you want to use and how much you can save on actual material that you could be using. Obviously, I don't have to go between the difference between concrete versus steel, also in terms of all the advantages that it actually gives. These are again some more examples. What we've basically done is we've compared a 4-meter column, which has the similar axial loading capacity of around 18,000 tons. We've tried 3 different elements. One is in terms of a built-up section where we're using a 500 depth, 500 flange, and 30 web thick and 50 flange thick. It has an axial capacity of around 18,000 tons. This is in 355 grade. You've used tubes, huge. I mean, like, obviously it has its architectural advantages. There is no doubt about it. It has really good moment of inertia capabilities in both the axes. It has its advantages, yes, but if I were to compare that same tube which has a similar axial capacity with what we can supply in terms of, so what I'm comparing is between a 350 grade and a 460 UV/UC section that I can supply. Firstly, I bring the weight down from a range of 470 kg per meter to almost 347 kg per meter. In the initial exercise itself, I'm reducing the steel quantity, which is directly proportional to the amount of carbon dioxide that you can actually save. Now, if I were to take a 4-meter column, a simple 4-meter column with an axial loading, which has to maintain about 18,000 kilonewtons of axial loading, the difference that we bring in is about 10 times. So, that's just one small difference. Earlier, SHIVANAND was mentioning about biophilic structures, about how steel can actually be much more compact in terms of getting more space. I know a lot of people over here have this notion that reinforced concrete buildings are always for residential. It is not necessary. That is something that you think. You think that concrete is going to be much cheaper compared to steel for a residential building, but look at the amount of this is an extremely, this is about 1.5 into 1.5 in reinforced concrete. But the difference that we can actually make if we bring it down into 0.48 into 0.6. That is the amount of difference without any change. Obviously then questions like fire protection come into place, but then we have developed various sorts of cladding, we've developed various sorts of concrete filled infills also for that. Again, the amount of carbon savings is almost 3 times. And I'm just taking one example over here. We see that a lot of people are now using composite in India. Again, our major point being that instead of having to use a built-up beam, we would rather suggest that you use a roll section. And if you want us to do any of these exercises, any of these design conversion exercises to compare what is it that you've designed and what is it that we can give you as an equivalence. We are not questioning your design in any manner, we are just telling you what is it that we can give you as an equivalent proposition and what is the saving that we can give you. We can do this exercise for you, including all the design curves. This was again concrete filled tubes, huge, gaining a lot of popularity in India, but then you know what are the complexities that are associated with having to use concrete filled tubes.